Example 1. A scientist recorded data collected by a rover sent to the planet Mars. The scientist recorded the time it took the rover to travel several different distances. Identify and interpret the constant of proportionality for the situation. In the table, we have time in seconds, that's our x, and distance in centimeters, and that's our y. The question's asking us to find the constant of proportionality. The constant of proportionality is just a unit rate. To find the unit rate, we do y divided by x. So in this table, we're going to record the data in the table as ratios of distance, which is our y, to time, which is our x. So our first ratio would be 10 over 2. The next one would be 30 over 6, 15 over 3, 45 over 9, and then the last one will be 20 over 4. Each of these ratios are in the form of y over x. Our next step would be to simplify each of these ratios. And you should know that a fraction is just a division problem. So all we're going to do to simplify is just divide. 10 divided by 2, that gives us 5. 30 divided by 6, that also gives us 5. 15 divided by 3 gives us 5. 45 divided by 9 gives us 5. And 20 divided by 4 gives us 5. Since every ratio is equivalent, the data are proportional. So we know that the unit rate is 5 centimeters for every 1 second. In other words, 5 centimeters per second. So to answer the question, the constant of proportionality, also known as the unit rate, is 5. It represents the rover speed, which is 5 centimeters per second. Example 2. The number of bracelets, y, that Reese can make in x hours is represented by the equation y equals 3/4 x. Create a table of values to represent how many bracelets Reese can make in 1, 2, 3, and 4 hours. What is the constant of proportionality in this situation, and what does it represent? Our first step in this problem is to use the equation y equals 3/4 x to calculate each y value. So we need to make a table. We have time, which is our x, and we have number of bracelets, which is y. The question tells us we have to figure out how many bracelets she can make in 1, 2, 3, and 4 hours. So we know the values that we need. For x, we need a 1, we need a 2, we need a 3, and we need a 4, because the time is in hours. Then we use our equation, y equals 3/4 x, to solve for our y values. So in the first column, we have a 1. So instead of x, we can replace that with a 1. 3/4 times 1 gives us 3/4. So our y value when x is 1 is 3/4. Using the same equation, y equals 3/4 x, we need to figure out what the answer will be when x is 2. So we replace the x with the 2. 3/4 times 2 would give us 6/4, because 3 times 2 is 6. And if you remember, a whole number is just 2 over 1. So 4 times 1 is 4. That can be simplified to 3 over 2. And if you turn that into a mixed number, you will have 1 and a half, because 2 goes into 3 one whole time, and you would have 1/2 left over. So to figure out the y when x is 3, we're going to use the same equation, and this time instead of x being 1 or x being 2, x is now 3. We multiply. 3 times 3 is 9. 4 times 1 is 4. And this also can be turned into a mixed number. 4 goes into 9 2 whole times, which would give you 8. And there's 1/4 left over. So when x is 3, y is 2 1/4. Now we have to do this for 4. So instead of x, we're going to use the number 4, or 4/1, turning it into a fraction, and then we multiply. 3 times 4 gives us 12, 4 times 1 gives us 4, and this can be simplified. 4 goes into 12 3 whole times with no remainder, nothing left over. Our next step is to identify the constant of proportionality. And remember, that's just the unit rate. When x equals 1, what's the y? And that's our constant of proportionality. We don't have to do any additional work because in our table, we have the value of y when x equals 1, which is 3/4. The equation also tells us the constant of proportionality. So the answer to this problem is the constant of proportionality is 3/4, and it represents the number of bracelets Reese can make per hour. Example 3. This diagram maps x values to y values. Is this relationship directly proportional? If so, identify the constant of proportionality. Our first step is to write ratios for each pair of values in the form of y over x. Our first pair would be 3/9. Our second pair would be 4/12. Then we have 5/15. Then we have 6/18. And the last pair will be 7/21. All of these are in the form of y over x. The next step would be to simplify each ratio. 3/9 can be reduced to 1/3 because both numbers can be divided by 3. 4/12 also can be reduced to 1/3 because both numbers can be divided by 3. Same with 5/15 and 6/18 and 7/21. So since each ratio is the same, the relationship is directly proportional, and the constant of proportionality is 1/3. Example 4. Two relations are described below. Determine whether each describes a directly proportional relationship or not. If the relation is proportional, identify the constant of proportionality. Relation A, the value of y is equal to the sum of x and 2. Relation B, the value of y is equal to 2 times x. So our first step in this problem would be to create tables to determine if the relationships are proportional or not. Relation A, the value of y is equal to the sum of x and 2. So that will be x plus 2. Relation B, the value of y is equal to 2 times x. So if we have an xy table, we can make up values of x. So let's pick 1, 2, 3, and 4. Same for this one. And now we're just going to substitute x for the values that we've picked. So our first one, we have x plus 2. When x equals 1, y would equal 3 because 1 plus 2 equals 3. When x equals 2, y will equal 4 because 2 plus 2 equals 4. When x equals 3, y equals 5 because 3 plus 2 is 5. And when x equals 4, y equals 6 because 4 plus 2 is 6. We're going to do the same thing for relation b, except for we're going to use 2 times x. So when we substitute x for these values, we will get all of our y values. So when x equals 1, y equals 2 because 2 times 1 is 2. When x is 2, y will equal 4 because 2 times 2 is 4. When x equals 3, y will be 6 because 2 times 3 is 6. And when x equals 4, y will equal 8 because 2 times 4 is 8. So now that we have our x and y, we can turn these ratios in the form of y over x for each relation, because that is how you identify the constant of proportionality. Y over x. So in our first relation, we have a 3 over 1, a 4 over 2, a 5 over 3, and a 6 over 4. If we simplify these, we get a 3, because 3 divided by 1 is 3. 4 divided by 2 is 2. 5 divided by 3 is just 5/3 or 1 2/3. And 6 divided by 4 is just 1 1/2. If you notice, we got 4 different answers. So that means relation A is not directly proportional. If it was, we would have got 4 of the same answers. So A is not proportional. Let's try relation B. If we turn all these ratios into y over x, we would have 2 over 1, 4 over 2, 6 over 3, and 8 over 4. 2 divided by 1 is 2. 4 divided by 2 is 2. 6 divided by 3, 2. And 8 divided by 4 is 2. So relation B is directly proportional because when we simplified all the ratios, we got the same answer each time. And the constant of proportionality is 2.